Today we are going to sketch a couple of quadratic graphs just to make sure we understand the processes we're going through and we can find all of the key points of information we would need to sketch a nice quadratic graph. So they are sketches, they're not accurate drawings, okay, so we're not going to get graph paper out, but we want to make sure our sketch is believable because there are certain conditions we would need to meet in order to score marks in an exam. Here we haven't specified exactly which things we'd want to put on the sketch, so we're just going to go through and find all the different things we might, so we could then select the appropriate bits we need when we're directed to find the different aspects of the sketch. So first one we've got here, we've got y equals x squared minus 5x plus 6. So key things we want to think about when we're sketching any graph really, not just quadratics, is to go through and think about what our shape would look like. There we go, managed to get my lid off. So I've got my shape of my graph. I want the roots. Remember, that's where it crosses the x-axis, so you can write x-intercepts if you like. I want my y-intercept. And then I might want an extra point depending on what sort of graph it is. So for the case of a quadratic, I might want the turning point. Okay, so in a quadratic, we might look for turning points. Other graphs, we might look for asymptotes or something like that. But here we're looking for our turning point. Okay, I don't know why I put a plural. Definitely only one turning point on a quadratic. So if we go through and then fill in which bits we can, hopefully nice and easily. So the shape. This is a positive quadratic, positive x squared, therefore it's a U shape, so we know that's the sort of shape we're trying to sketch onto our graph. Fine. For the roots, we're going to solve it equal to 0. Remember, it's where it crosses the x-axis, y equals 0. So if I write a 0 here, I'm then doing my normal factorise and solve if I can. So in our cases then, if I take x squared minus 5x plus 6 equal to 0, I can then factorise that into two brackets, does factorise quite nicely, minus 2, x minus 3, so therefore I get two roots of x equals 2 and x equals 3. Okay, so there's our roots that we can add onto our diagram shortly. Y-intercept, nice and easy when we're given the equation in expanded form. If I put x is 0 for my y-intercept, this disappears, 6 is all that's left. So my y-intercept then is 6. And then for the turning point, now at A level we've got two options for turning point. In the case of a quadratic, we've got two options. We can either complete the square, or if we're at the point where we've done differentiation, we could go through and do the differentiation to find it. So, assuming we're early on in the year at this point, I'm going to do it by completing the square, GCSE method, something we should be familiar with. Good chance to practice that anyway. So here, if I want to complete my square for this, I'd have y equals x minus 5 over 2. Okay, so I halve my coefficient there. So x minus 5 over 2 all squared minus 25 over 4. And then plus 6. So if I then simplify this a little bit, so minus 25 over 4 plus what would be 24 over 4, gets me minus 1 over 4. So I have x minus 5 over 2 all squared minus 1 over 4. So I now know what my turning point would be. Remember, I can now read it off. So it's this coordinate in here, but remember to swap the sign. So it's 5 over 2, and then this value on the end is my y coordinate, so minus 1 quarter. So this is all the information I would want to gather to sketch a quadratic. As I said, in an exam they might only specify points where it meets the axes, or they might only specify turning point. Here we've got everything we could possibly need for our graph. So we're going to go through and add all this stuff onto our diagram. So we'll start with the roots, so 2 and 3. So again, believable, doesn't need to be perfect. Looks like it's kind of, that's where 2 and 3 could be on my axis. 6, so again, kind of mark that on, so put that somewhere. And then 5 over 2 minus a quarter would be in between 2 and 3. Remember, it is halfway between for your turning point. So if I mark that on and put 5 over 2 minus a quarter, I can then see how the shape will fit in around those points. So I'm going to come down through the 6, through the 2, the turning point, and then back up through the 3. So it's really easy to see. So let's see how well this is going to go. So we're going to come down here, through that point, turning point, back up there. Not bad, not bad, okay? So things to look out for, make sure it doesn't start curving back on itself, and ideally make sure it doesn't look like it goes vertical either, because quadratics don't do that. So if it looks like it does, might lose some marks on your sketch, okay? So there's our list. We're going to do the same thing this time for our second one. So we're going to write down our shape and look for that. We're going to do our roots, we're going to do our y-intercept, and we're going to do our turning points, TP this time. So shape, this time, still a quadratic. It's got all important minus in front of it, so it's going to be our N-shape quadratic that we hopefully remember. For our roots, exactly the same idea. We could set it equal to 0. Now, Here, we could put it in our calculator. We could show the method. I'm going to show a method, but I'm going to remember that because it's minus x squared, that can make things difficult if I'm going to show factorising, because it's a little bit harder to figure out. So you're going to have a minus x in one bracket and a positive x in the other. Because I put it equal to 0, I can just change the signs for the whole thing. Okay, and now it's just more user-friendly from a factorising point of view, because now I can just fill in my two brackets as x minus 6 and x plus 2. So I get my two roots as 6 and minus 2. They are not affected by doing that process. So I don't need to then go through and change the sign and put minus 6 and plus 2. Those are the correct two roots, 6 and minus 2. Okay, so we'll take those, put them on our diagram in a minute. Y-intercept, as we said before, nice and simple when it's in expanded form. 0 here, 0 here. It's just going to be a 12. Put that one in. And then our turning point, we need to complete the square. As I said, I'll stick with the same method. Slightly more difficult version because it does have the minus, but it still works. Take the minus out of the whole thing, or well, I do it as my first two terms using my square bracket. So positive x squared minus 4x, and then my plus 12. So a little bit of practice out of completing the square. So now inside this bracket, I do my x minus 2 squared minus 4, close my square bracket, put my plus 12, and then remember that this minus now applies to both of the things inside this bracket. So I end up with, making sure I've got room to sketch, minus x minus 2 squared. Then I would end up with minus minus 4, so plus 4, plus 12, so I get plus 16. So my turning point coordinates are 2 and then 16. Remembering again, that minus in front of that bracket makes no difference to what's going on inside. It's still x equals 2 is the value that we want. Okay, so we've got all the information we want. Time to transfer that onto our sketch. So starting with our roots, we've got minus 2 and 6. So we put minus 2 here and then 6 a bit further out. Again, believable. Y-intercept we know is 12. Wrote that down here, so we'll put that on somewhere up there. And then turning point is 2, 16. So 2, 16, so somewhere up here. Should be halfway between our roots. And again, you can see how the shape will fit in. If we'd made a mistake somewhere in one of these, maybe our y-intercept ended up down here or something, you should be able to spot that your shape won't work, right? But my shape is going to work up through this minus 2, the 12, the turning point here, down through minus 6, down through positive 6, all good. So let's see how this one goes. First one was quite good. So we're going to start down here. Let's go up, through, turning point here, and then down, something like that. There we go. Not bad. Not bad sketches today. Okay, so it's meant to be a fairly simple process. We just make sure we're ticking off all the boxes. For exam type questions, make sure you check which information you are required to show on your sketch. But this is how we would find a complete sketch for a quadratic and all of the bits that we would need to mark on. Okay, let me know in the comments if you're good with all this sort of stuff, or if there's some useful bits there that we can use. Good chance to practice your completing the square. Hit that like button and subscribe for more help with your A-level maths.